juniors. This video is going to be on Packet Tracer 9.3.4. Ms. Pierce reached out to me, told you guys we're looking for a little bit of help on that. So I'm going to get this video up on YouTube for you guys to look at. So first thing we're going to do is come over here and open up that file. As you guys can tell, I'm doing this off of my Mac. It's going to look a little bit different than your guys' Packet Tracer on Windows, but it's all essentially the same thing. All right. I'm not going to go over this background scenario with you guys. You guys can read that on your own. So we're going to get right into it with step 1A right here. We're looking at how is the branch office physically connected to the data centers. So we come in here, and Packet Tracer has this nice feature where if we just hover over something, it'll give us some information about it. I promise it does. Hold on. Let's zoom in a little bit. There we go. So if we hover over this cable right here and we look at that last sentence right there, the cable type is fiber. So that's going to be our 1A answer right there. How is the branch office physically connected to the data centers? Just go over the topology real quick. You guys read in the scenario right there, we have our data center locations in Seattle and Toronto, and then over here in Winnipeg, we have our branch office, and it's connected through fiber to the data centers. What logical configuration in the branch office provides redundancy? That's going to be our 1B question. So let's go over here into the branch office. And obviously we have our physical redundancy right here, the multiple links between each device, but we're looking at logical redundancy. And our logical redundancy that's going to be between sites is going to be on our router. So we got to go into our router right here. And if we're looking at redundancy between routers, it's going to be in the routes they have. So your immediate thought is probably, okay, well, I need to look at the routing table to see if that tells me anything. So I'm going to go ahead and do a show IP route, but it doesn't give us the information we need. You guys should know when you're looking at a routing table, the best routes are only what's going to be listed in there, not every route that is configured on the device itself. So instead of that show IP route, we're going to run a show run pipe command right here. Just to go over this again, I believe I went over it with you guys before, but that pipe command is used to parse information. If you don't know what I mean when I say parse, it's going to include a certain amount of information out of a long list of information. So if we look right here at show run pipe and we do question mark, we can include, exclude, section, or begin with a certain type of information. So we just want to look at the routes right here. So we're going to show run pipe include IP route, because we know in our running configuration when we're configuring routes, we're going to use an IP route command. So we come in here and right away it's sticking out to us, right? For every route in here, there's another route that is configured as a floating static route. So to go over those floating static routes for you guys, floating static routes are when a administrative distance is added on to the command, to the IP route command, in order to make it less preferable to another command. So this is administrative distance right here. This 10 is representing administrative distance. You guys would know a directly connected route has 0 AD, a normal static route has 1 AD. So if we want to have it float above that other route, we're going to put, a 10, a 2, a 4, a whatever, something larger than 1 right here. So that's going to be your 1B answer right there, is that floating static routes are configured for redundancy. How is data center 1 connected to data center 2? So we're going to expand right here. We're going to go back out to our main topology. And we can just hover over this link again. Right there, last sentence, fiber. So that's your 1C answer. It's configured with long distance fiber. How are the devices in data center 1 physically organized? So we'll go over here to Toronto, drill down a little bit, data center 1. And right here, you guys can kind of just talk about what you see in this layout right here. We're looking at a very redundant and high availability oriented architecture right here. We have more than one of each device, and each device has redundant links running between each other. You guys can see right here, it's highlighted with purple when I go over it. All right, so that's going to be your 1D answer right there. 1E, does the data center 2 equipment layout differ from data center 1? So we'll go back out, head over to data center 1, or 2, sorry. And no, it is the exact same. Quick 1E answer right there, it does not differ. Why is the physical organization of the data center devices important? You guys can even relate this to what you have going on back there in the lab. If you don't understand if the layout of the devices in a rack or a data center aren't logical and are easy to understand, it's going to be difficult to get to them. They're going to be difficult to troubleshoot, and it's going to make your life not fun. So that's going to be your 1F answer right there for troubleshooting and management purposes. Okay, step 2. How are the devices named in the data center? So we'll go over here to Toronto, join the data center 1. Look at this guy. Sorry, just making sure my AirPods were working. And how are the devices named in the data centers? We don't have to drill in. We can, if you want to, you can go into the CLI and look at the host name and all that, but we'll just stay out here. DC, that's not what I want. That's the, okay, DC1B and DC1A router. So they are named by location and function. So we're in data center 1, and this is a router. Same thing for the other devices. Data center 1, master switch A, so on and so forth. How are the devices addressed in the data centers? So we can look at our servers for their IP information, and right here in rack 0, we can see fast Ethernet 0 and fast Ethernet 1. They have an IP address of 172.16 and 10.16 with a 1.1 for the third and fourth octets, and it just increases as we go between rack 11.1. This is going to be 21.1. This is going to be 31.1. Same thing for the other rows and racks, you guys can see. So that's your addressing scheme for the devices in the data centers. For a 2C, why is the naming and addressing of the data center devices important? Same thing we were just going over in step 1. You know, I need to know where these devices are at, and it needs to make sense to me. If these just have random IP addresses that skip around, they're going to be very difficult to manage. It all has to seem logical. Step 3, we're going to go to data center 1. We're already there. Rack 0. Data center 1, switch A. So we're going to go right here. Give me 1 second just to pull those directions on another screen. Let me just make sure I'm in the right place real quick. We're on step 3. Okay. We're looking at what technology is used to provide redundancy and stability in the switch's configuration. So you guys can see in the physical topology right there, we have multiple links running between each device. So if we want redundancy between the links, we know that's what we have ether channel for. So we're going to go in here and we're going to do a show ether channel just to see if that's active. And what do you know? It's active. We have one group running it with 2 ports in that configuration. They're using LACP. So what technology is used to provide redundancy and stability in this configuration? For step 3B, we're looking at ether channel using link aggregation control protocol. You guys should also know that is the vendor neutral / open source version for port channeling. You're going to be looking at PAGP, port aggregation protocol, for the Cisco proprietary version. And what is the purpose of this technology? Just went over that. Bundling links provides redundancy and load balancing. What is the total bandwidth over port channel 1? So we'll drill down a little bit right here. We're going to do a show ether channel summary. It's going to give us some more detail right here. You can see we have 2 ports in here, and they are fast Ethernet ports. You should know by default, fast Ethernet ports operate at 100 megabits per second, and obviously a gigabit Ethernet port operates at 1 gigabit per second. Sometimes fast Ethernet ports can be a little bit funky though and not be the speed they are supposed to be by default. So we're going to do not a show ether channel, we're going to do a show interface on one of those interfaces real quick, just to make sure they are operating at the expected speed. Go in here, look at the show interface output. We have 100 megabits per second. So for what the bandwidth is of port channel 1, we have 2 interfaces that are going to be operating at 100 megabits per second. So that makes a 200 megabit per second bandwidth. 3E, what will happen if the fast Ethernet 0/1 port on DC1 R0 switch A fails and why? The bandwidth will just decrease. Like I was saying, it's load balancing, it provides redundancy. So you're still going to have that link there. It's just not going to be the same speed you had when you're using 2 interfaces. So we'll get out of this real quick. Come on. There we go. Step 4, We're going to be looking at the router this time. And it's asking what technology is used to provide redundancy in their configuration. This is chapter 9 for you guys. Routers, layer 3 devices. What is layer 3 redundancy? That's going to be your first hop redundancy protocols. We're probably going to be looking at HSRP right here since these are Cisco devices. So let's drill down into the router right here. If we want to look at what is going on, well, we even see right here we have HSRP running, but that's not what's going to be given to us. So we'll do a show standby. And HSRP is running because we have active and standby statuses right here. So that's going to be your 4B answer, is that HSRP is running on these devices. What's the purpose of this technology? Layer 3 redundancy. If one router goes down, the other picks up the slack. Active and standby roles. 4D, if I'm correct, 4D. Which router and interface will be used as the default gateway for the 172.16.0.0/16 network, and why? So right here, if we look at group 1, we have this IP address for the virtual IP that the routers are sharing right here, and that is in the same subnet we were just talking about in the question. So we know the default gateway is going to be this address right here, 172.16.0.254, that the routers are sharing. And then we need to see what interface that's going to be. So first we need to make sure that what router that interface is on. So if we look more into this output, the active router is local. So this router is the active router for this standby group right here. So we can do a show interface, or show IP interface brief, sorry. And we can find the interface that has an IP address in that subnet. It's going to be fast Ethernet 0. So to answer 4D, we're going to be using this fast Ethernet 0/0 interface with a default gateway of .0.254 for the forwarding in that subnet. 4E is just asking the same question, but basically for the other group, which router and interface will be used as the default gateway for the 10.16.0.0/16 network, and why. Let's look at group 2 right here, and there we go, 10.16.0.254. But it's a little bit different this time because the active router is not this one. This standby router is local. So we're going to have to look at the other router just to confirm the interface real quick. We already have the IP address of .0.254, but we'll go to the other router and just do the same thing we just did. Getting here into the CLI. Enable to get into global privilege exec mode. We're going to do just a show IP interface brief to confirm what interface we're looking at, and it's going to be fast Ethernet 1/0 because it's in that same subnet. So that's your 4E answer. All right. Part 2. Nope. Part 2. Okay, so now we're looking at the layout in here, and it's asking for rack 5, which would be this empty rack right here that I've already filled out with the equipment that is over here. You guys would just drag that over. When new switches are required, how should they be connected, and what should their names be? So if you guys look at these switches, right, we're looking at 2960s right here, which is extremely outdated. Cisco stopped selling these around 2005 and went out of support around 2015. So you guys can do some research if you're not sure, but you're going to be looking for some updated switches to put in there. Not just one bladed switches. You might be looking for something more robust and more modern. And what should their names be? If we want to keep the same scheme, we can go by, just the data center. But if we want to get more specific, we can say data center 1, rack 0. This would be, row 3 for our device. How are the rack 5 switches connected to the rack 0 switches? The same way every other rack is. We're going to be going from our master switches right here that go to the links on every other switch. You can see them highlighting in purple as I go over them right there. How many servers should be added to rack 5? How should they be configured, and with what addresses? So we were talking about the IP schema earlier. If we look at our our servers, we're not really going to be needing to do any subnetting here. It's pretty logical what the schema is. It goes up by 10 in the third octet every time we go between racks. So we're looking at 11.1 right here on fast Ethernet 0. We're looking at 21.1 right here. We're looking at 31.1 right here. We're looking at 41.1 right here. And this would be 51.1. So using that same logic, you guys can figure out your answer to step 1C right there. How should the servers be connected to the network? Upstream to their corresponding switches in the rack that they're in, the same way they are in every other rack. How would the above information change for adding a new rack to DC2? The name and addresses would be different. That's it. It's a different location, so you're going to be using data center 2, but we're still going to have racks and rows, and then the addresses are obviously not going to be the same. I'll skip over this a little bit since I already did it for you guys, but you're just going to drag the physical devices from over here into the rack and then configure right here what it tells you to do. If you're confused on where to do that at, just click on the device, go over here to the config tab, and right here you put in your name. Configure IP addressing for the servers in rack 5. So it's asking for our DNS and default gateway addresses right here. The same way we were just talking about the IP schema. We're in the same section of the network, so everything's going to be using the same DNS. Did not mean to draw down. Same DNS and default gateway addresses. So if we hover over right here and look at our addresses, 10.16.0.254 and 172.16.11.1, and that's just going to replicate all the way over here to rack 5. Same logic applies for this table I want you guys to fill out right here. So looking at, data center 1, row 5, switch 1, keep in mind that addressing scheme that increases by 10 in the third subnet each time it goes through. And you guys should be able to fill out this table. And it's going to ask you to put those addresses on those devices. Right here, it's asking you to put a host name on the switch. That can be done in the config tab. It wants us to do it on this guy over here. You can do it in the config tab, or you can go in the CLI right here, type host name and the host name that you want. Connect cables, you guys should be able to do that on your own. You should be able to figure out what ports are what and what cable is what. And if we don't know what a copper straight through cable is for some reason, let's go back right here. Solid black line, that's your straight through cable. Right here, once you can configure Ether channel with LACP on these devices, it gives you guys the commands for that, so I'm not going to go over that. And then it just says to repeat it on switch B. It's going to be the exact same commands just on that switch. And then we want to verify that the ports have been aggregated. So the same way we were verifying before, just do a show ether channel and a show ether channel summary to make sure that the aggregation is running on those switches. These reflection questions, I might go over a few of them. Let me read them real quick. These guys you should be able to answer on your own. Yeah, a lot of these are just asking about the importance of redundancy, which we covered already, and you guys should know in your curriculum. But if there are any questions on that, just comment them on the video or reach out to Ms. Pierce, and I'll make sure to get back to you guys on that. But other than that, you guys should be good to go on this packet tracer. Best of luck, and let me know if you guys need anything.